Now we are starting off with the prep up for the net examination uh, ahead in this month, and here are some PYQs that I'm going to discuss, especially the first one beginning today. We'll be discussing a PYQ. This was from the exam of June, which was held in July, actually, June 2024, which was uh, the question based on Simpson's one-third rule. So let me write the question first. So here's the bit which asks us that the integration of that given equation, that is integration from 0 to 1 of 2x over 1 plus x squared times of dx, is estimated using the Simpson's one-third rule with a grid value having h is equal to 0.5. Now the difference, which is the difference between the estimated value, which is obtained obviously from Simpson's one-third rule, and the exact uh, integration, that difference will be closest to the following options have been provided. We'll have to choose the correct one. That is 0.007, 0.001, 0.0007, and a negative of 0.005. We'll see which of the answers or which of the options is correct. So for the answer part, the solution part, we'll have to consider first. Let's check the exact integration. That's pretty straightforward. Now you can take y is equal to 1 plus x squared. It seems pretty straightforward, so I'm taking it like that. So y is equal to 1 plus x squared. Now dy will obviously be equal to 2x dx. So what you know is from these two cases that you have integration from 0 to 1 to be equal to, well, 2x dx is simply dy, and this is over y. So this is going to be ln of y taken from 0 to 1, which means it is obviously what was y is equal to 1 plus x squared. So ln of 1 plus x squared taken from 0 to 1, and that is equal to, well, if you put x is equal to 1, then you have ln 2, and obviously the other one is going to be ln 1, which is obviously 0, so we need not be concerned about that. But this ln 2 is approximately equal to 0.693. This is the exact value. Let's check what we are getting from the Simpson's one-third rule, the estimated value. Well, the integration is going to end up with a value that is equal to h over 3. This is the estimated one, h over 3. This is from Simpson's rule, and you have, because the highest power here is x squared, so what we know is we are going to have three of those values: y naught 4 times of y1 plus y2. This is what we are going to have, and y naught and y2 are the two extreme values, while y1 is the middle value, because the grid has been provided with a value of 0.5 taken from 0 to 1. That is the integration through which we are doing, which we will be carrying out. So we'll have to take the grid as first up we'll be taking 0, then we'll be taking 0 to 0.5, then 0.5 to 1, the difference being equal to 0.5 in each case. So this is how we proceed in this case. So having those values, we can put the value of y naught and y2, the extreme values, and this is for y1. Now this is just to be placed in case of the function. So y naught is simply equal to the function that is there, that is f of x. So instead of x, you will be putting the value of x as, these are the values of x. So these are to be put over there. So 2 of 0, so this is going to be 0. And then if we are to determine y1, then y1 for x, we'll be putting the value of x in this integrand that we have, that is 2 times of x. Instead of x we have 0.5, so 2 times of 0.5 over 1 plus 0.5 squared. So this, the upper value goes to 1, while the lower value 1 plus 0.5 squared is 0.25. So this is 1 over 1.25. You know, 1 over 1.25 is simply 5 by 4. So the 5 stays there and the 4 goes up. So this is 4 over 5. So that is the value of y1. And then we have the value of y2 to be equal to, instead of x, you put the value as 1 over there. So 2 times of 1 over 1 plus 1 squared is nothing but equal to 2 over 2, which is equal to 1. So these are the values of y2, y1, and y0. We put that over there. H, as we know it, is 0.5 over 3, and y0 is 0, and 4 times of y1 is simply 4 times of 4 over 5. And then finally y2 is equal to 1. The bracket, we have 0.5 times of over 3, and 4 times of 4 is 16, over 5 is 3.2, plus 1 is 4.2. 4.2 goes cancels with 3 as 1.4, and half of that is going to give me 0.7. So this is the value of the estimated value that we have obtained, and the difference, the exact value as we know it, is this one, which is the exact value is I, we take it as I exact, and this is I estimated, and the difference, as we can see, it's heading towards the first option. Let's just be sure about that. I estimated minus I exact is equal to, well, I estimated is this one, 0.7 minus 0.693. 700 minus 693 is just 7, but you would have you'll be getting two zeros prior to that in the decimal case, so 007. So this is the first option which is provided to us, and as the answer for the first of the PYQ that we did. We'll be doing more PYQ. This was just a short video that I just wanted to start today, and we'll be doing a lot more in the upcoming videos. So stay tuned for that. Till then, thank you for watching.